NextGen is, in concept, a comprehensive overhaul of the technological, procedural, and regulatory aspects of the air traffic control system. It is a transition from ground-based navigation systems and radar surveillance to satellite and ground station navigation and surveillance. At the core, NextGen incorporates a surveillance system known as Automatic Dependent Surveillance Broadcast, ADSB, which uses GPS technology that are capable of providing more precise surveillance information, eliminating the latency of traditional radar. Greater precision allows air traffic controllers to make better informed decisions regarding aircraft movements. ADSB is a very significant component of many NextGen technologies being produced and tested in Daytona Beach. NextGen integrates new and existing technologies, policies, and procedures to provide a better travel experience, preserve aviation's economic vitality, and enhance safety. The Florida NextGen Test Bed, FTB, is a cooperative FAA and Embry-Riddle Aeronautical University initiative to provide a NextGen research and demonstration facility at the Daytona Beach International Airport. It serves as a forum to help foster NextGen partnerships with industry, academia, and the government by providing a facility where new prototype capabilities can be tested, evaluated, and demonstrated. It provides an open platform to help evaluate and examine the feasibility of new technologies. NextGen will help ATC surveil higher demands of air traffic more accurately with greater update rates, improving the situational awareness for pilots and controllers, contributing to a safer flight for everyone. Embry-Riddle's role at the Florida NextGen Test Bed is to act as the prime contractor and a non-biased arbitrator, bringing together partners or subcontractors for constructive collaboration. The corporations actively participating at the Florida NextGen Test Bed include, but are not limited to, the Boeing Company, who is participating in a collaborative information sharing project facilitating interagency governmental systems communication harmonization. Lockheed Martin, the vendor of systems like ERAM, the En route automation modernization system, TBFM, the time-based flow management system, and ATOP, the Advanced Technology Oceanic Procedure System. Harris Corporation, the vendor of the NAS Enterprise Messaging Service, which enables the sharing of system-wide information that enhances global ATC communications. Mosaic ATM, a system vendor who supports surface monitoring systems with its surface decision and support systems. And the Daytona Beach International Airport, which is the home of the Florida NextGen Test Bed. The test bed is divided into two parts. The Integration Suite, which serves as a platform for industry partners to integrate their systems and ready for demonstration. There are 4 functional areas in the Integration Suite. The Integration Area, which allows engineers to work together on development, testing, integration, and related activities either separately or collectively. The Video Conference Room, for meetings and teleconferences which can accommodate approximately 20 people with a high degree of technology. And the Data Center, with a state-of-the-art networking hub which integrates the Demonstration Suite with the Integration Suite and also the Test Bed with the Near Lab located on the ERAU campus. Once systems are integrated and prove to be working, they are moved to the Demonstration Suite for testing. The Demonstration Suite is at the core of the FTB mission and is used to conduct demonstrations of the operational capabilities deployed at the FTB. Designed to accommodate flexibility and future growth, it contains reconfigurable bay areas positioned along the periphery to accommodate demonstrating and visualizing different flight domains or operational areas. The Demonstration Suite consists of Electronic Flight Strip, EFS, a switch from paper-based to automated electronic strip solutions. It reduces the controller's manual workload significantly, increasing efficiency and safety. The data appears on a large 15-inch to 21-inch touch-sensitive computer display. A stylus pen, keyboard, or mouse could be used to manipulate the strips and associated data. The main benefit of EFS is that it could be connected to any source of flight data such as AFTN, FDIO, ADEXP, or other FDP systems. Surface Decision Support System, SDSS. The primary object of the SDSS is to identify, prototype, and validate advanced surface traffic management capabilities. It displays flight information and surface and the terminal area aircraft positions to air traffic controllers and traffic managers, flight operators, airport authorities, and other specialists at the operational facilities of aviation organizations involved in the airport surface operation. Airport Surface Detection Equipment Model X, ASDX, is a surveillance system using radar and satellite technology that allows air traffic controllers to track surface movement of aircraft and vehicles. It alerts air traffic controllers of potential runway conflicts by providing detailed coverage of movement on runways and taxiways. By collecting data from a variety of sensors, ASDX is able to track non-transponder equipped and transponder equipped vehicles and aircraft on the airport movement area. En route automation modernization, ERAM, intends to be the backbone of the NAS. It adds new capabilities needed to support the evolution of U.S. national airspace system, improves information security, streamlines traffic flow at U.S. international borders, processes flight radar data, provides communication support, and generates display data to air traffic controllers. Advanced Technologies in Oceanic Procedures, ATOP. ATOP program replaces oceanic air traffic control systems and procedures with a satellite-based integrated oceanic system. It allows oceanic controllers to be in touch with aircraft in mid-oceanic flight and allows properly equipped aircraft and qualified aircrews to operate using reduced oceanic separation criteria. This enables more aircraft to fly optimal routes, enhancing aircraft flight time efficiency during oceanic legs of their flight. It also has research, analysis, and simulation tools like Total Airspace and Airport Modeler, TAM. It is a fast time and real-time simulation model of simulated targets. Using TAM, airports and airspace can be modeled, and then impact of changes to infrastructure, operations, and schedules can be evaluated. It enables the operator to identify the system benefits of changes such as building a new taxiway, or re-architecting sectors, changing runway configurations, or determining when saturation will be reached. It allows users to create an unlimited number of what-if scenarios, testing new concepts and operational parameters in a virtual environment. Performance Data Analysis Reporting System, PDARS. It is a historical playback tool used to research flight trajectories and to generate statistical reports for research and development. The information comes from systems at air route traffic control centers, ARTCs, terminal radar approach control, TRACON facilities, and ground-based systems which track aircraft along its path. And Metroplex Simulation Tool. The Metroplex Simulation Environment, MSE, is a flexible simulation environment for conducting terminal airspace and airport surface experiments. MSE simulates the airport surface and/or the terminal airspace in detail. It provides a simulation framework and default capability for data input and output for evaluating traffic management algorithms. The FTB is currently working on multiple tasks that will greatly improve the National Airspace System. Some of the projects being conducted are System-Wide Information Management, or SWIM. SWIM provides secure and flexible information management architecture for sharing advisory and enabling increased common situational awareness. It enables information sharing between divergent systems on the ground with increased interoperability and common situational awareness. The use of service-oriented architecture technology allows software applications in the NAS to interact with one another through information services that can be accessed without knowledge of an application's underlying platform implementation. This simplifies interface requirements to existing NAS systems and ensures new systems can be built with minimum technology constraints. As a part of SWIM, several industry partners are working together to demonstrate the use of an electronic flight bag for accessing SWIM information in the airplane's cockpit. The SWIM project also includes Mini Global, which demonstrates the applicability of a global exchange information for flight, aeronautical, and weather information, or FIXM, AXM, and WIXM. It engages with ANSPs, flight operators, and air traffic management, ATM industry. It promotes harmonization of standardized global exchange models and demonstrates integrated use of related next-gen enabling technologies. The aim is to increase global predictability by addressing seamless operations, integration of systems, and effective cross-border operations. Mini Global data shows how the FAA, INSPs, and flight operators in both the Pacific and Atlantic regions will be able to share common information to improve collaborative decision-making, air traffic management, and promote international harmonization. Another project being worked on at the testbed is Airborne Execution of Flow Strategies, or AEFS. AEFS increases collaboration between national airspace system stakeholders. Currently, ATC has limited awareness of airline operator handling preferences or priorities. In addition, the airline operators have limited insight into the ATC bottlenecks or operational constraints. By promoting methods to increase collaboration between flight operators and ATC, AEFS improves the traffic flow management efficiencies, situational awareness among stakeholders, and flexibility in the use of NAS. AEFS works by transferring delays from high priority to low priority flights within the same fleet without affecting the non-fleet aircraft. It serves as an alternative to time-based flow management. AEFS was performed using Metroplex Simulation Environment Modeling and Simulation tool. AEFS fleet prioritization has 4 use cases that were evaluated during lab demonstrations and modeling and simulation exercises. Airborne to airborne, prioritization among airborne flights only. Airborne to ground, prioritization with ground flights being higher priority over airborne flights. Ground to airborne, prioritization with airborne flights being higher priority over ground flights. And ground to ground, prioritization among ground flights. The Florida NextGen Test Bed is a major player in the process of implementing, prototyping, demonstrating, and reviewing future concepts. NextGen does not have an end. It is an evolution on a daily basis which slowly improves our airspace system through our collaborative efforts and ongoing research and development. Through NextGen, we will stay current, relevant, and remain a leader in aviation. We will continue to work towards innovation and improvements for years to come with proven systems pioneered at the FTB. Florida NextGen Test Bed, working together to help shape the future of aviation.